Welcome to this tutorial on damage stability. Tutorial number 620 focuses on the deterministic damage stability method. So what we're going to go over today is the deterministic damage stability process. How you damage compartments, apply stability criteria, and combine all that into a stability analysis. And then we're also going to cover damage stability automation. I'll touch on that very briefly, but it's really worth talking about right now. But before we get into any of that, a brief disclaimer. So this presentation is for instruction purposes only. It is not to be used in engineering for construction, and I'm not a representative of Creative Systems. So everything you see here is unofficial training based upon my own knowledge and experience. For the official training, you can contact Creative Systems at the information on the bottom of your screen. I highly recommend it. It's very informative. Okay, so the damage stability process. Basically what I want to say is that damage stability is not entirely special. Damage stability is essentially the same process of intact stability, only you're repeating it again and again and again for different buoyancy configurations, different damage cases. So you can see basically step number one is before you've even done any analysis, you look at your vessel to determine what the sets of damage cases are. And usually in deterministic damage stability, what that is that you'll have some regulations that apply to establish some extent of damage. And we'll talk about that. And you'll use that to create the damage cases. Now that does depend on your regulations. Now after that, you apply one damage case, damaging one or more compartments. You then apply any healing moments that might apply. You equalize your vessel to that new equilibrium position, and you apply your stability limits. Now once you've turned on your stability limits, as we know, that only defines the limits, so then you have to run your righting arm curve to actually check those limits. Or you generate a max VCG curve for all the different drafts. And then here's the part, step number 7. This is where damage stability really becomes a lot of effort. Is steps 2 through 5, and really 2 through 6, I really should say. You repeat that for every single damage case, and possibly for multiple load cases. So you can see how it has the potential to be basically repetition of a very simple concept, but you're going to be repeating it quite a bit. So step number 1, the extent of damage. Like I said, this is usually defined based on regulations, but the regulations are going to essentially define a box. That's saying this is the farthest that any damage would penetrate into your hull. And that box will usually be defined in all 3 dimensions, so you'll have a length, a breadth, and a depth to it. And what you do is you take that box and you lay it along the side of your hull. This is usually really better to do if you have a GA of some type. But you lay it along the side of the hull, and you find out, pushing that box along, what are all the possible combinations of compartment damage. And that includes combinations of tanks and compartments. So, we are considering each individual tank here as a possible combination. And what you're trying to really do is find any possible scenarios that create uneven weight distribution, uneven buoyancy distributions. There are a couple caveats to that. Normally you do not damage across your main transverse bulkheads. If you're a passenger vessel, you often do. So that's one of those areas that depends on the regulations, and you have to read pretty carefully there. The other catch here that usually helps reduce your amount of effort is you look for symmetry. If your tanks and your compartments are all perfectly symmetrical on both sides of the ship, then you only have to damage one side of the ship, because you know the other side will behave the same way. So once you've done that, you go through your vessel and you create a list of combinations for compartment damage. These are all the possible combinations. And each combination is what we would call a damage case. And so you'll have a list of compartments that are damaged in each damage case. And this could be a pretty extensive list depending on the complexity of your vessel. Once you have that, we go into step 2. So you take your first damage case and you apply the damage case. So that's using the GHS type command, and you're going to damage multiple tanks probably, depending on your damage case. And you want to make sure that everything else is set to intact. So you generally will start by saying everything is intact and then specifically damage the things that you have. So you can review tutorial 610 for information on the type command. And then step number 3, now that we've applied that damage case, we're going to apply any healing moments. Now again, the healing moments, this is just the same as the intact stability analysis. So there might be wind healing moments, it might be an arbitrary moment, say from a crane, or it might be due to vessel churning. All of that, again, depends on the regulations that describe exactly what healing moments are required. You can take a look at tutorial 530 for more information on how to apply healing moments, but it's generally with the GHS command of HMMT. So look at that. Okay, we've put on our healing moments. Now we have to equalize the vessel. So notice this vessel's going to equalize quite a bit because you've damaged it first off, so it's lost quite a bit of buoyancy, and you've possibly applied a healing moment as well, so it's trying to heal over. So when you equalize that vessel, notice it's going to move around quite a bit, and like I said, make sure that you've applied all the damage before you equalize it. Next we use the GHS solve command, and that's going to be solving, well, for example, you might solve for weight, LCG, and TCG. More likely you're just going to issue the solve command on its own without any of the parameters, which means it will solve for draft, trim, and heel, and that will allow the vessel to equalize its position. You can find more information on that in tutorial number 420. Right, now we turn on our stability limits. Now those limits, you're defining them here. Again, what they actually are, that is set depending on the regulations. Now, you might be tempted here to, if you see multiple regulations that apply to your vessel, you might be tempted just to code all of the regulations into one massive set of stability limits. Don't do that. Check each set sequentially. So check each regulation sequentially, because that's going to help you isolate any problems if your vessel does not pass any of those regulations, and you'll be happy to have a more limited set to work with. So again, the GHS command for all of this is the limit command, and there's a very extensive tutorial on that, tutorial number 510, but it's essentially the limit command, and then you've got all the various limit specifications that you can apply. Right, so now you're on to step 6, where you're going to actually check those limits. So you can run the GZ curve using the RA command, and of course you want to check it against the stability limits at the same time, so you have to include the dash or the LIM option and possibly the margin. Tutorial number 520 provides information on that. Alternatively, you might decide instead that you want to run the max VCG command instead. You can do that. You can actually run max VCG with damage turned on. That works. And this is fairly worth taking a look at. Generally, in vessels, damage stability is what ends up governing your max VCG limits. So you can find more information about that in tutorial number 550. Okay, and then here's the fun part. Step 7, repeat. So everything we just showed you, steps 2 through 6, that was running through a single damage case. And now for step 7, you're going to repeat that for each one of the damage cases that you came up with. So that's basically, you're going to copy and paste the same code again and again and again, and the only thing that you're really going to change is what tanks are being damaged. Now, since you're copying and pasting things, one of the things you really want to make sure is just basically completely reset your vessel between every single damage case. So you're going to want to set all of your tanks to the intact condition. You're going to actually want to explicitly tell your vessel that it has a heel of 0, that's upright. You're going to set the trim to 0 as well. and possibly re-equalize the vessel as well before you apply your damage cases again. Now, the reason for all of that is that you might actually have some damage cases that cause the vessel to completely flip over. Now, that makes it very hard for GHS to recover from a flipped over condition to re-equalize. So you just want to tell the vessel or tell GHS to reset it to the correct heel. And it just gives you a good stable point to start from every time. And then what you're doing is while you're iterating through all of this, you're going to track it in a report. Now, there are some things that you want to do to help you keep track of what's actually going on as you iterate through all of this. So generally, you're going to want to update your subtitle to show you the current damage case at all times. And you're probably going to want to update that also to show the current load case and the current stability criteria, because there's quite a bit of stuff that you're going to iterate through here. So use your subtitle command to help keep track of all of that. Okay, so that is the 5-cent version of how to do a damage stability analysis. Now, I also mentioned something about automation. Now, you've noticed from what I've described so far that there are going to be a lot of lines of code that are essentially just repeats. It's the same code being typed over and over again. That's kind of a problem in programming, because that means that there are many opportunities for typos. There are many opportunities for you to get something wrong. Now, what you'll eventually want to do is you'll want to replace those with GHS macros. And that's getting into advanced scripting in GHS, but it's really something you want to do because that's where GHS really becomes powerful and worth the effort of learning everything. So what a macro does is it puts all the code in a single block, and it lets you reuse that block of code multiple times, basically acting as a function. So if you want to learn more about GHS macros, you can go to the tutorials on GHS scripting. Tutorial number 810 covers GHS macros. I will say that this automation here, that is the beginning of using GHS as a programming language. And that's where you're really going to discover the versatility and customization ability and power of GHS. It's going to let you automate and do a lot of work very, very quickly. I've actually seen GHS automated to the point where a stability analysis might take one person 3 days, whereas it was automated for this other person. They had automated it so far that the same stability analysis took approximately 10 minutes. So that gives you an example of the power of automation for GHS. Right, but this isn't just about talking. Time to practice this yourself. So, homework number 621, I would like you to perform a damage stability analysis on the barge. The homework has a loading case already provided, and I'm not going to give you any regulations to look up, so I'm just going to tell you the extent of damage. It has a length of 4 meters, a breadth of 2.3 meters, and a depth that is unlimited. So this is a horizontal box, 4 meters long, 2.3 meters wide. So anything that's 2.3 meters in from the side shell, that gets damaged. Anything, and you use that 4 meter length long to determine how many combinations of tanks get flooded at one time. Now, I will say that this is what the Coast Guard calls Type 1 damage, so it is not going to damage across transverse bulkheads. Right, so make sure you look at it to identify where the main transverse bulkheads are and do not damage across those. Now, what damage cases do I want you to develop? I would like you to develop all the possible cases. Remember to take a look at symmetry. You only have to do both sides if it's not symmetric in that section. And then I want you to show the condition graphics for each damage case. That's really useful to be able to see what the damage actually looks like. And then show the vessel status for each damage case. So then, that's going to show also the equalized status. And now, once you've done all of that, now we need to check the stability of it. So here are some made-up stability criteria. Like I said, these are just criteria that I've created. They don't match any real regulations. But you want at least 0.05 meters of positive GM at equilibrium. That is meant to be at least. You want a margin line that is not immersed at equilibrium. Area under the curve of 0.03 meter radians from equilibrium to 40 degrees, or the angle of downflooding, whichever is less. Alright, so now that you've applied those stability criteria, time to check them. So run your GZ curve for each damage case, check stability criteria. Don't worry if it passes or not, I just want you to check them. And then for extra credit, check the max VCG for each case as well. And that's going to be running a draft range of 0.5 meters to 4.75 meters with just level trim. Okay, well, thank you very much for watching. I hope you have found this informative and useful. You can find the tutorial file along with solutions and other useful tutorial videos on dmsonline.us. Thanks very much.
Thanks for watching. I hope you liked it. Hey, did you know that there is a magic button down below? Click the like button or even the subscribe button and I will make more videos for you.